All right, here is that problem. I worked it out. Sorry, I forgot to record it, but there you go. Pause it and take a look through it. I guess we don't need this equals 8 pi more anymore there. Okay. All right, let's take a look at example 6. It says, find the volume of the solid generated by resolving. I think that's revolving. Oh, no. By revolving the region bounded by y equals the square root of x and the lines y equals 1 and the line x equals 4 about the line y equals 1. So let's take a look at this one. And we're going to try and think our way through this together. So we have this. We have that same square root function, right? But this time it says we want it bounded by the line x equals 4. So that's this line. This is x equals 4, right? X equals 4. And bounded by, and it's between that and y equals 1. So we can put in a y equals 1 like this. Y equals 1. This one is y equals square root of x. And so this is what we want, and we want it revolved about the line y equals 1. So we're not revolving it around the x-axis. We're revolving it around y equals 1 like that. All right. So let's think about it just like we did before. Let's say we come out here to some point on the line or in our part. We want this area in here, right? We want to revolve it that way. So I'm going to take this to be my radius, whatever it happens to be. And then I'm going to revolve it around into a circle like that. And we're going to get this kind of shape right there. Okay. And that's the volume we're looking for. So what I need to do is figure out what is this radius right there, just in general for any point that I happen to pick along there. Any x value I give you, what will that r value be? Huh?
I was thinking it would be since it's been raised to y plus 1 and b minus 1 for whatever radius we get.
Nope, it's not just minus 1. Huh?
Minus the square root of 1. That's just 1. I'm just guessing.
It's okay. Let's look at it. Let's say we take a look at this and we say, all right, this is the radius we have coming up from the axis for square root of x, right? And then we also have this coming up to y equals 1. So isn't r just the purple arrow minus the orange arrow? I think that's what you were trying to get at, right? Y'all see that? So the purple arrow is simply square root of whatever x's happens to be there, right? And so we're saying r equals, and the yellow orangish one is just 1. You see that? That's our radius for any point along there. Now, we have to figure out one more thing before we do this, and that is where exactly do we start here? In other words, what is this value here? Because we're not going all the way back to 0. What is that value? 1. That's when these two equal each other, right? 1 equals the square root of x, that's just 1. So this is at 1. So our integration limits are going to be from 0 or from 1 to 4. And this is the radius thing we want to integrate, right? So we want to integrate. In other words, we want to add up all of this stuff, pi r squared, right? Except this r, I guess I shouldn't write it that way. So say r is a function of x. I should put that in there too. This is r as a function of x. Okay? So pi r as a function of x squared dx from 1 to 4, right? And so that's our tiny little thing. Now, that is just, so anyway, this pi r sub x squared part, that's just an area, but we're multiplying it by some sort of height, right? So that makes this a what again? Just like in the last one? It's a volume. This is a volume because we have we have this area times this thickness. That's a volume. So this is our volume. And so this is integral from 1 to 4 of pi times square root of x minus 1 squared dx. What? It's written on mine. It's written here, but not there. Uh-oh. Zoom messing up on me here.